Greetings, M squared, and we are going to continue solving triangles, but this time we aren't going to have any angles. So last time we did this, we had one angle and one side, and today in all our problems we're going to have two sides, but no angles. So to find the angles when you're given sides, you need to know about inverses. So cosine, sine, and tangent, you use those when you have the angle, but when you don't have the angle and you need the angle, you're going to use inverse. So we call it inverse cosine. This is when you see this, we don't say cosine to the -1 power. That -1 actually is not an exponent. So when you see a -1 on a sine, cosine, or tangent, then that means the inverse. So what happens in all inverse functions is that x and y switch places. So for example, if I said the cosine of 60 was 1/2, because the cosine of 60 is 1/2, this is considered the x and this is considered the y. Well, in a cosine inverse, the angle never goes here. The angle always goes here, and the y part goes there. So you'll notice that these just switch places. So when you have sine, cosine, or tangent, the angle always goes here. You always have to find the sine or cosine or tangent of an angle. But when it's a cosine inverse, sine inverse, or tangent inverse, you never take that of an angle. It's always the ratio. So the angle and the ratio switch places. That's the most important thing you have to know there. The angle and the ratio are switching places. And then you just need to know how to say it. You're going to say inverse cosine or the inverse of cosine, something like that. So when we need an angle, we're using our inverse functions. Let me explain to you how to do it in your calculator. So if I say the cosine of 60, it tells me it's 1/2. If I say if I use the second function, that green button here, it's probably a different color on yours. You can't see it. Let me show you. This little green button here. And then you see the cosine here. Above the cosine, you'll see a little cosine to the -1 power, sine to the -1 power, tangent to the -1 power. So when you hit the second function and then cosine, the inverse pops up. And remember, we don't put the angle in there. We put the ratio in there. In fact, look what happens when I put 60 in there. It tells me I have an error. So we don't want to do that. We're going to go back and we're going to put the 1/2 in there, and we're going to get 60. So when the inverse of cosine, it's saying, hey, what angle would I have to get in order to get a ratio of 1/2 for cosine? And the answer is 60. Okay, so let's get started. So first of all, you can find this side using Pythagorean Theorem if you want to, or you could find the angle and then use sine, cosine, or tangent. So this first one we'll just find the side first using Pythagorean Theorem. So this is the hypotenuse, so we're going to say 30 squared equals 24 squared plus a squared. We'll just call it a squared. So that's 900. What's 24 squared? 24 squared is 576. And so I'm going to take 900 minus 576, and I get 324. So 324 equals a squared. I believe that's the square root of 18. So let's see, 18 times 18. The square root is 18. Yes, so this equals 18. So now that I have that, I can find my angles. Because remember, when we're solving triangles, we're finding all the missing sides and all the missing angles. Once I find C or B, though, then I can just subtract from 90, because I remember that the acute angles of a right triangle are always complementary. So I'm just going to shoot for C. So we're going to say, and now that we have all the sides, we can use sine, cosine, or tangent. It doesn't matter. I'm going to just use sine. So I'm going to say the sine inverse, right? The sine inverse of, and then I'm going to put the angle here, because remember the angle always goes up there. And now I need to know what the ratio is. So it's opposite over hypotenuse. So I'm going to put 18 over 30 here. Now that's reducible, but you're putting this in your calculator anyway, so I don't reduce it. So I'm going to say sine inverse. I'm going to say 18 over 30. Use my fraction key for that. And this is the number I get. Notice it's an irrational number. It's going to go off the screen. So I am going to round, and all angles, they're asking us, most of the time you hear angles are round to the nearest degree, sometimes it's tenths of a degree. We're going to do degree here. So this would be 37. So I'm going to round that angle to a 37. And then I don't have to do the same process to find b because these are complementary. So all I have to do is take away 90, ignore the negative because I took 90 away, and that's going to be 53. So I know that this one is 53 degrees. So it's not as much work if you use the Pythagorean theorem there, and then if you just do the complementary. You don't have to go through all that again. Okay, let's try another one. Here we go. Again, to find this side, I can use Pythagorean theorem. This time let's not, so we'll practice. Okay, so if I'm talking about angle B, then what two parts do I have? I have the adjacent and the hypotenuse. That's cosine. So I'm going to say cosine inverse of 32 over 51 equals b. My goal is to find b. So I get my calculator out. I say cosine inverse. That's 32 over 51, just double checking. And it's going to tell me what b is. And if I'm rounding to the nearest degree, then I know that's 51 degrees. So I say, okay, I've got a 51 degrees, and then what would this one be? Well, all you have to do is take away 90, and it's 39 if I round it up. Okay, so now I can use those angles with sine and cosine or tangent to find this side. So let's use that one. I'm going to use sine. So I'm going to say the sine of 51 degrees is equal to, we'll call this x over 51. Oh, that's weird. They're both 51, so that's a little confusing. I'll put a little degree there so you know that that's the angle and that's the side. Okay, so I'm going to multiply, cross multiply, so I get x equals 51 times the sine of 51. So 51 times the sine of 51 is equal to 39.6. And this time I'm going to round to the nearest tenths because usually links around to the nearest tenth, so 39.6. So x equals 39.6. And we have found all our parts. Alrighty. Let's see. We are going to, let's try another one. I'm going to only do one of these, and then I want to get to this one because this one looks a little strange right there, but I want to make sure we get to that one. So we're going to ignore that one. So I look at what I have according to y, and I notice it's the adjacent and the hypotenuse. So I'm going to say cosine inverse of 11 over 20, and I want it to be y degrees because they're calling this y degrees this time. So I just put that in my calculator, cosine inverse, second function cosine, and I'm going to put 11/20, and I get 56.6. If I'm rounding to the nearest degree, that's 57. So y equals 57 degrees. And if y equals 57, I can say 90 minus 57, which is 33. So then I know that x is 33 degrees. And then I can use Pythagorean theorem. I'll do that one again. So 11 squared plus I don't know squared equals 20 squared. So that's 400 minus 121. That's what that one's going to get me. 400 minus 121 is 279. So 279. A squared equals 279. I notice that 2 plus 7 is 9, plus 9 is 18, so I know that's divisible by 9. I'm going to get it in simplest radical form. Divide it by 9. That's a prime number. So I know that a squared is equal to 9 times 31. And I can take the square root of the 9, but the 31 doesn't have any perfect square factors in it. So my answer is just 3 times the square root of 31. Okay, now I want to talk about this one. So what kind of triangle is that? Well, it has two marks on it. Those two sides are the same, so it's called an isosceles triangle. Well, what happens when I drop an altitude on an isosceles triangle is it turns into two congruent triangles. The reason I have to do that is because I can only use my sine, cosine, and tangent ratios in right triangles. They didn't tell me it was a right triangle. So now I have two right triangles. The other thing an altitude does, even though I didn't draw it really beautifully, is it splits the base of the isosceles triangle into two congruent parts. So then I know that if the whole thing is 5, that each one of those is 2.5. Now I know that it's 2.5, I can actually just use that right triangle, the 6 and the 2.5, to find, I don't need to find this, but I need to find this angle. Once I find this angle, I'll know it's the same as this angle, which helps me find the third angle. Okay, so that's really all I need, right? They gave me all the sides. The only thing I need to solve this triangle are to find the angles. So if I want to find this angle, I'll call it A. I notice that it's got the adjacent side and the hypotenuse given to me, so I'm going to use the cosine inverse of the adjacent over the hypotenuse. So I'm going to put that in my calculator. Again, no need to reduce, get the decimal out because you're just putting it in your calculator. So inverse cosine of 2.5, this time I'll say divided because sometimes my fraction key doesn't like to have decimals and fractions, but dividing, remember the fraction bar means division anyway. So I just said 2.5 divided by 6. So I get an angle of 65.37, but since I'm rounding to the nearest degree, I'm going to call that 66. And if I call this one 66 because it's an isosceles triangle, I'm also going to call that one 66. And if I take 180 and I subtract 2 times 66, because there's 2 of them, I get 48, so that my last angle is a 48. So again, that was 180 minus 66 minus 66 equals 48. That's how I got that. Okay, so that's how you find angles, missing angles, using trigonometry, right triangle trigonometry. So good luck with that. M squared, signing out.